Hey there, ladies and gentlemen. Welcome to Lesson 9.7. Lesson 9.7 is absolute value equations. It's not us solving them so much this time. It's us being able to graph the absolute value equation. So the way that this works is we have our parent function, just like when we had quadratic equations that we were graphing. Our parent function is the function in which all functions come from. So our parent function over here is just the function of y is equal to the absolute value of x. Now if I were to graph that function, the easiest way to graph these things is to just make an xy table and then plug numbers in. So I'd plug numbers in like -2, -1, 0, 1, and 2 into this and find out that I got 2, 1, 0, 1, and 2, which provides me with this graph. Hey, look, people are interrupting with the announcements. So I find that to be my parent function, and then everything happens from there as we change the parent function's original stuff into other things. All right, so here's an example. You can't see these words, I need to bring them down. It says that we are supposed to describe how each graph, my absolute value bars didn't come with, is different from the parent function and how it is like. All right, so again, here's our parent graph. It's going to be our graph in red. So our function, where we have the absolute value of x and then plus 3, all that does is change my graph to go shifting up 3. Now they have the same slanted sloped line, but then they are going up 3 spots from the original that little V spot. So this is just going to translate up 3, and that's what we need to be able to describe for how it's different. The same thing is it has the same exact slopes. Now if you look at our question B here, absolute value of x and then -4, same idea. It's the same exact type of a slope, the green one, but it shifted down 4 spots. So this one is a translate, because translate means to shift, translate down 4. That's really good handwriting. You guys should be impressed. Yay! All right, so that's the easy stuff, us being able to describe those things. And again, all you would really do is you'd make an XY table if you didn't know how that worked out. So you just plug in numbers as a -2, -1, 0, 1, and 2 and get your answers. And that's going to give you the easiest way to make these things make sense for us. All right, so here's another one. This one, they want us to graph it. So we are actually going to now make the XY table. We're not just going to use, hey, I know it's supposed to go up 5. We're going to see and prove that it goes up 5. So I have a -2, a -1, 0, 1, and 2. So at -2, so a -2 plus 5 is 7. A -1 turns into a 1 plus 5 is 6. And then 0 plus 5 is 5. 1 plus 5 is back to 6. 2 plus 5 is 7 again. So I go to the left 2 and up to 7. 1, 2, 3, 4, 5, 6, 7. Put a dot. Go to the left 1, go up to 6, 0, and then here's, oopsies, I made a wrong move there, folks. Don't tell anybody. Lots of wrong moves. All right, now we'll go back up again. And that's how many points we've graphed. So we should be able to, from there, see that it's going at a slope of +1 this side and a slope of -1 on this side. And the whole thing just got shifted up 5 spots from my numbers. All right, folks, let's do another one. So this one, same idea, absolute value of x, and then it says -1 on the outside. So if I plug in my numbers, a 2, sorry, I got quickly interrupted there. A 2, absolute value of -2 is 2. 2 minus 1 is 1. A absolute value of a -1 is 1. -1 is 0. 0 minus 1 is -1. And then 1 minus 1 is back to 0, and 2 minus 1 is back to 1 again. So if we graph all those, to the left 2, up 1, to the left 1, 0, 0 down 1, to the right 1, let's see, at 0, and then to the right 2, up 1, you'll see that again my graph was just shifted entirely down one spot. That was a really bad graph drawing skills, but we gotta get to more important things here. So writing an equation from absolute value equation from just knowing that it goes 8 units down. So here's what we're gonna do. We have the absolute value of x, and then it's gonna go minus 8 because it's 8 units down. This one's gonna be the absolute value of x, and then it's going to be plus 6 because it said 6 up. Absolute value of x, and then plus 2, and the absolute value of x, and then minus 5. Now these are all the simple ideas here, folks, because it says 5 down, we're going to have a minus 5. It says 2 up, we're going to have a plus 2. It says 6 up, we're going to have a plus 6. We get the point, right? All right, so let's make things a little bit harder. Sometimes things are going to look a little bit different when we have stuff going on the inside of the absolute values. So if I'm plugging numbers in, absolute value, I'm going to get 3, 2, 1, 0, 1, 2, 3. And I'm going to graph all of those points now, because that's what y equals, in black. So I went to the left, went up 3, 1, 2, 3, up 3, 1, 2, 3. Left 2, up 2, and this is my parent graph. Now I'm going to do the exact same math over here. I plug in a negative 3 minus 3 is negative 6, absolute value of negative 6 is 6. We should change colors. That way this all makes sense. I'll go red this time. So that's 6. A negative 2 minus 3 is at negative 5. Absolute value of negative 5 is 5 because the absolute value, again, is distance to 0. And then we're going to get a 4. And then 0 minus 3 is negative 3, so we're at a 3. 1 minus a 3 is negative 2, so we're at 2. 2 minus 3 is at 1, and we're at 0. So we're only going to get part of a graph here, it looks like. So I'm at negative 3, 1, 2, 3, and then up to 6. 1, 2, 3, 4, 5, 6. And then we went down like this the entire time. Now, I know that because if I plug in a 4, and 4 minus 3 is 1, so I'm going to start going back up now. And that's going to be what my graph in red looks like. So what happened in this one? It shifted to the right 3 spots. That's important for us to be able to see. So a minus 3 on the inside made it shift to the right 3 times. Let's go blue this time. A negative 3 plus 3 is 0. A negative 2 plus 3 is a 1. A negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 5 and 6. We're going to have the exact opposite situation happening here, I believe. So we went to the left 1, 2, 3 and got 0. To the left 2 and got 1. So if I were to plug in that same 4, and 4 minus or plus 3 is now at 7, right? So we were going to be going this way. What we need to do is plug in a negative 4 to find out what's happening. Negative 4 plus 3 gets us to back going up to 1. So now I can see that that was my vertex of this graph, making things go back upward. So if you notice now, my graph from the parent graph has now shifted, or translated would be a better math word, because it said plus 3 to the left. So some key things here. We're basically going to do the opposite. So for a positive number h, it translates the graph h units to the left. For a positive graph with h being negative, it translates the graph h units to the right. Now that's what's taking place here, folks. That's what we're going to end up graphing today with our absolute value functions. Again, remember that if you don't know how to graph any of these things, you can easily just make a table, plug numbers in, If you need to extend your table like I did with these two so that we can find out exactly where that V vertex takes place, I think that's a pretty good idea. All right, folks, this is the Berman Nation. Hopefully solving and graphing absolute value functions is easy for you. We're signing off.